Hi, this is Mrs. Rodriguez, your algebra teacher. This video is a review for the Chapter 12 test that's coming up, which is the last test of the semester. Okay, so what I recommend that you do is as you watch this video, when a problem comes up on the board, please pause the video and then try to solve the problem yourself, and then watch my explanation. And if you get the problem correct, great, move on to the next problem. If you get to the end of the video and there's a couple of problems that you missed and you don't understand my explanation, please call, text, email me, or stop by my office hours, and I'll be happy to go over those problems with you. Okay? All right, let's go ahead and get started. So this is a review for the Chapter 12 test, and the questions are from a practice test on page 817 of your textbook. Okay? All right. So first section talks about samples and studies. So some types of samples are simple random, systematic, convenient, self-selected, and stratified. Okay, so you should know the definition of each one and be able to identify each type. And then 3 study types are the survey, observational, study, and experiment. Okay, so you should know the difference between each one of those. So problem number 11 says the second graders are divided into boys and girls. Then 2 girls and 2 boys are chosen at random to represent the class at the Pride Assembly. Which of the following best describes the sample? Okay, so we have a group, a population that is divided into 2 subgroups, and then within those subgroups they're taking a representative from a small sample of representatives from each of those groups. So that would be a stratified sample. Okay. All right. And then problem number 6 says to identify each sample as biased or unbiased, and it says to explain the reasoning. So it says a survey is sent to all the people who describe to the dispatch, which is a newspaper, to determine what newspaper people prefer to read. Okay, so this is obviously going to be a biased sample, because if the people that they're asking already subscribe to Dispatch, they probably already really like that magazine, and that's why they subscribe to it. So most of them are probably going to pick that magazine. Okay, if they liked a different magazine, they would, or a different newspaper, they would subscribe to a different one. Okay. All right. And then problem number 7 says each person leaving the Maxtown Mall is asked to name their favorite clothing store in the mall. Okay, so this would be an unbiased sample, because everyone in the store is being asked, or every person that's leaving the store, and they could be there at the mall for any of the clothing stores that are in the mall. Okay, so it would not produce, if they were asked standing outside of one specific clothing store and asking people what their favorite store was, then that would be biased, because if they're in that store, they probably really like that store, so that would create a biased sample. But if it's at the if they're asking people that are leaving the mall, they could have gone into any store in the mall. Okay. All right. So here, problem number 1 says Rico is selling candy. If Marissa randomly selects 2 candy bars to purchase, what is the probability that she buys a milk chocolate bar followed by a caramel bar? So we're being asked about probability. So we're going to divide the number of favorable outcomes by the number of total outcomes. So we want to know if she buys a milk chocolate bar. Okay, so there are 8 milk chocolate bars, so that would be the favorable outcome, over the total possible outcomes. So there's 8 chocolate bars, 6 caramel bars, 5 dark chocolate bars, and 6 peanut butter bars. So that would be 8 over 25. Okay, and then followed by a caramel bar. So we're going to multiply by the probability of getting a caramel bar. So there are 6 caramel bars, but now if she already took 1 chocolate bar, then now there's only 24 types of chocolate bars left. Okay, so we would multiply 8/25 times 6/24, and we can see if we can cross simplify anywhere here, and we can. So 8 goes into 8 and 24 have a common factor of 8. 8 goes into 8 once, 8 goes into 24 3 times. And then we also have a common factor between 6 and 3. So 3 goes into 3 once, and 3 goes into 6 twice. So this would be 2 out of 25, which as a decimal is 8/100. And we change that decimal to a percent by moving our decimal 2 times to the right. So that would be 8%. So there's an 8% chance of Marissa randomly selecting a milk chocolate bar first and then a caramel bar second. Okay. All right. So then the next lesson talks about statistics and parameters. The mean absolute deviation is used to predict errors and judge how well the mean represents the data. A low standard deviation indicates that the data tend to be very close to the mean, while a high standard deviation indicates that the data are spread out over a larger range. Okay? So here it says to find the mean, median, mode, range, and standard deviation of each data set that's obtained after multiplying each value by the given constant. Okay, so the first thing I want to do is put my data in order from least to greatest. Okay, and as I'm doing that, I'm going to cross each set of data off so that I know that I already accounted for that set of data. Okay, so we've got 2 17s and also 21, 25, and 31. Okay, so there's 2 ways I can solve this. I can find the mean, median, mode, range, and standard deviation of this set of data and then multiply that by 3. Or I can multiply each set of data by 3 and then find the mean, median, mode, range, and standard deviation of that data. Okay, so that's what I'm going to do. So I'm going to multiply each one of these by 3. Okay, so that would be 27, 27, 27, and then 36, 39, 17 times 1 would be 50, or times 3 would be 51, and then 63, 75, and 93. Okay, so then to find my mean, I need to add up all of these values together and then divide by 10 because there are 10 pieces of data in this data set. Okay, so if I add all of them together, I get 489, and then I'm going to divide by 10. So my mean is 48 and 9/10. Okay, then for the median, remember that is the middle set of data when your data is in order. So all my data is in order right here. Okay, and there's 10 pieces of data, so halfway between the 5th and the 6th piece of data would be my median. Okay, so 1, 2, 3, 4, 5. So this is the 5th and the 6th piece of data. So I would add those two together, 39 and 51, and divide by 2. So that ends up being 45. Okay, and then the mode is the most common set of piece of data. So the mode is obviously 27. And then finally the range. Now the range is the difference between the highest set of data, so 93, and the lowest set of data, which is 27. So we subtract those and we get 66. Okay. right, and then it also asks for the standard deviation, okay? So on page 759, it explains how to, there's a formula for standard deviation, okay? All right, so basically, you're taking the square root of the mean, the value of the mean, which in this case is 48 9/10, and you're subtracting each value in the data set, so 27, and then you're squaring it, and you add that. You do that to each set of data, so 48.9, there's 3 27s, so you would have to do that 3 times. And you continue to do that for each set of values. So you do that for all 327s, 36, 39, 51, 51, 63, 75, and 93. And you divide all of that by the number of data, which in this case is 10, okay? So obviously you're doing this in a calculator, okay? Make sure you're doing this in a calculator. And once you punch all those in, the standard deviation ends up being 21 3/10. Okay? So please, please, please make sure you're doing this step in a calculator. Okay? Whether you're using a scientific calculator that you have or like Desmos, that would be a good one to use as well. Okay? All right. So here, number 8, it says, Nate is keeping track of how much people spent at the school bookstore in one day. Find and interpret the mean absolute deviation for the data, okay? So in order to find the mean absolute deviation, the first thing you need to do is find the mean, okay? So this data is already in order, which doesn't really matter for the mean, but just noting that it is. So you would add all of the data together and then divide by the total number of data in the set, which is 7. So when you add everything together, you get 28, and when you divide by 7, you get 4. So that is the mean, okay? So then in order to find the mean absolute deviation on page 758, it gives you the formula where you would take the absolute value of the mean, so in this case it's 4, minus each data set. So here would be 4 minus 1, okay? And then you add the mean again, so 4, and subtract. You're doing that for each set of data, okay? So we have a 2, so we're going to subtract 2. We have a 3, so we're going to subtract 3. We have a 4. We have a 5. We have a 12 is the last one, okay? And then you're dividing all of that by the number of data, which is 7, okay? So if we were to simplify this, this is 4 minus 1 is 3, so we're taking the absolute value of that. Again, 4 minus 1 is 3, 4 minus 2, 4 minus 3, 4 minus 4, 4 minus 5, which is 1, 4 minus 12, which is negative 8. And then, so we simplify that. The absolute value of 3 is 3. The absolute value of 2 is 2. The absolute value of 1 is 1. The absolute value of 0 is 0. The absolute value of 1 is 1. And the absolute value of negative 8 is positive 8. And we divide by 7. And then we end up getting 18 over 7, which is 2 57 hundredths. Okay, so that is the standard the mean absolute deviation. Okay, so it says to interpret it. So it's the value is influenced by the outlier, because if you notice, this part of the data is pretty close together, but then we have this 12. So we would consider that an outlier. And without that in the data, you'd have a mean of 2 and 67/100. Okay, so if that set of data wasn't there, the mean would be 2 and 67/100, and then the mean absolute deviation would be 1 and 33/100. So this would be obviously the lower the value, the closer the data is together. Okay, so that's what it means by interpret. Okay, you want to explain the difference if the outlier wasn't there. Okay, if this value was lower, then your interpretation would be, okay, the data is very close together. If the number was really high, you could say the data is pretty spread out. Okay. All right. So distributions of data and comparing sets of data. So here it says in a negatively skewed distribution, the majority of the data would be on the right. So if we had our data, like most of it would be over here, this would be a negatively skewed data. And in a positively skewed data, the majority of the data is on the left. Okay, so this would be positive. And then in a symmetric distribution, the data are evenly distributed. Okay. All right. So number 3 says use the graphing calculator to construct a histogram for the data and use it to describe the shape of the distribution. Okay, so we have this data set. If you have a graphing calculator, you would put it in to create a histogram. If you don't have a graphing calculator, then I recommend using this site. Pull it up real quick. Let me share it with you. Okay, so this is, I just Googled Desmos histogram, and right here, this one, if you scroll down, it's called Easy Histogram Maker. Okay, so if you click on that, here it is, a histogram maker, and you just enter all of your data here. So you would start entering your data one by one, and then at the bottom you would hit generate. Okay, and then when you do that, I've already done it, so sorry, let me pull that up. So when I did that, this is what my histogram ended up looking like. Okay, so obviously most of the data is going to be on the left-hand side. Okay, so that means it's going to be positively skewed. Okay, positively skewed. All right, so again, all I did was enter my data into that website, and then this is the histogram that it gave me. So if you don't have a graphing calculator, and so this would be a positively skewed. Okay. All right. And then the next section talks about simulations. Simulations are used to perform experiments that would be difficult or impossible to perform in real life. I don't believe you have any questions like that on the test. Okay. So permutations and combinations and probability of compound events. So a selection of objects in which order is important is called a permutation, and a selection of objects in which order is not important is called a combination. For independent events, the outcome of one does not affect the outcome of the other. Okay, so number 9 says, how many ways can 3 different toppings be chosen from a list of 10 toppings? Okay, so this is going to be a combination because the order does not matter. If you're talking about a pizza, let's say you want cheese, pepperoni, and sausage. It doesn't matter if you order cheese, pepperoni, and sausage or sausage, pepperoni, and cheese. It's still the same 3 toppings, okay? So the order doesn't matter. Okay, so this would be a combination. Okay, this would be a combination, and we would enter 10 and 3. And we end up getting 120, okay? So you might be wondering, okay, how to get that? So you should have a graphing calculator that has this key. Gets like this, okay? If not, you can use Desmo's free scientific calculator online. This is what I use. I don't have a regular scientific calculator. And so this is what it looks like on the main page. So you would look for that key. So you go on function, and here it's at the bottom, it has the N, the C, and the R. So you click on that, and then the set of parentheses opens up, and you would put 10, 3. You hit enter, and then you get 120, okay? So there's 120 different ways you can choose the 3 toppings out of the 10, okay? So this would be 120, okay? All right, and then problem number 2 says a die is rolled 200 times. What is the experimental probability of rolling less than 3? Okay, so they want the experimental probability. So when asked, okay, what is the probability something happens? We would calculate the probability that way, right? Dividing the total favorable outcomes by the total number of outcomes, right? But experimental probability is what actually happened, okay? So they did this experiment, okay? They rolled a die 200 times, and they got 1 this many times, and 2 this many times, etc. Okay? So we want to know the probability of getting less than 3. So in other words, less than 3 does not include 3. So we want to know the probability of getting 1 and the probability of getting 2. Okay? So the probability of getting 1, they got it 30 times, and the probability of getting 2, they got it 26 times. Okay? Out of a total, they rolled the die 200 times. So the number of favorable outcomes would be how many times they rolled a 1 and how many times they rolled a 2. So that would be 30 plus 26, which is 56. And then divided by the total number of outcomes, which is 200. You divide that, you get 28 hundredths, which is 28%. Okay. All right. And then the last section talks about probability distributions. Okay, so for each value of x, such that x is between 0 and 1, the sum of the probabilities of each value of x is 1. And then the expected value of e of x of a discrete random variable of a probability distribution is its weighted average. Okay, and I don't believe you have any questions like this on the test either. Okay, all right, so thank you so much for watching. Hopefully this video was helpful to you. If you are at this point in the video and you still have questions, of course, please call, text, email me, or stop by my office hours, and I'll be happy to help you. Okay, you have a great day and good luck on your test.